welcome to True Projects. In this video, we are going to discuss about the project which is DisCOV distributed COVID-19 detection on X-ray images with Edge Cloud collaboration. So before getting into the execution, let us understand what is the project about. So this COVID-19 problem, that is COVID-19 disease, has really put a strain on hospitals as well as doctors worldwide. This COVID-19 virus, it spreads super fast, takes a long time to show symptoms in some people, and even when it shows symptoms, it can look different from person to person. So, to stop it from spreading, we need to find out who has it as quickly as accurately possible. So, traditionally, PCR X rays were used to figure out if someone has got this COVID 19 using some certain signs, especially in their lungs. But here is the tricky part, there are so many people needing tests and not enough resources to test them all fast enough. So we need to come up with new solution to test quicker and in more places. So what are we going to do in this project is we are going to develop an efficient system, that is automated system, that will accurately and quickly detect COVID-19. So the author in the base paper, he has proposed the system called distributed COVID-19 detection on X-ray images, which is DisCOV. So this combines edge and cloud computing to enhance COVID-19 detection efficiency. He utilizes edge computing for rapid image pre-processing and cloud-based AI for analysis. So this disk curve minimizes latency and it optimizes this resource usage. He has employed lightweight models based on training the algorithm distributed across edge devices and the cloud to reduce transmission latency. So he built all these models, that is DiscoverNet, Inception V3, MobileNet V2 based LDT algorithm, SqueezeNet based AlexNet. So he has built all these models for the comparison. This is his proposed model. So in our project, what did we do is we used all these models and we built all these models. So when we evaluated all these, for us, MobileNet V2 based LDT algorithm, it has performed well, which means it has achieved highest score. So what did we do is we deployed this model for detecting the COVID-19. So moving on to the flow of the work. First, we started by looking at the COVID-19 image data and figured out important features. Then we cleaned it up for data checking for any missing values and filling them. We also make images easier to understand by creating histograms. After that, we adjusted the images in various ways to help models learn better. Next, we split our data into two groups, one for training our models and one for testing them. Then we built different deep learning models. These models are like super smart brains that can recognize patterns. And we also create simple website using Flash where people can upload images when someone uploads an image. So using Flask, we have deployed our project. So we deployed MobileNet V2 based LDT algorithm in the Flash based frontend. So moving on to the front-end integration, we have integrated Flask for building the web interface. Flask is like a lightweight web framework for creating websites using Python. We use it in this project to make a website where people can interact with our COVID-19 detection system with Flask, and we set up features like sign up and sign in using a sample database called SQLite3. Users can upload images on the website for analysis. Flask helps to manage all these interactions by directing them to the right parts of a project, where the images are processed and predictions are made. In this way, users can easily use our project through a web browser. So we thank Flask for making everything work smoothly together. So moving on to the software and hardware requirements, we need software and hardware requirements to implement this project. So software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So coming to hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So moving on to the algorithms used, these are the models which are built in the project. I already told you that these are the models which are built in the base papers. So we have utilized same models for detecting COVID-19. So this COVID-net was according to the base paper, that is, this COVID-net is a proposed model in the base paper. And this model has performed well to them. But when we built in this project, so MobileNet V2 based LDT algorithm, it performed well for us. So this main algorithm is LDT and this is based on MobileNet V2. So MobileNet V2 is the backbone for this LDT model. So we have deployed it in the project. So let's execute the project. To execute it, we have to open the code folder which contains source code files. So this is the code folder of the project. And here we have all the source code files. So let's understand them individually. How will they be used in the project? In the first folder, we have the data set. So here we can observe that there are two folders. One is train and the other one is test. In train, we have images of chest x-rays. So we use all these images for training all the models built in the project. So these are the models. Sorry, these are the images that are used for training. So now get back. Here in the test folder, we have images. So these are the images which are used for testing the models. So get back. In train, we have 5,309 images and in test, we have 624 images. They are in the ratio of 8:2. So we use train model, that is train folder, to train all the models and test folder to evaluate all the models. So we use train images to train the models and test images to evaluate the models. So get back. Here in the sample folder, we have two subfolders. One is COVID and the other one is normal. So we'll be using these images as the test cases in the front end to detect COVID-19. So these are the images of COVID. These are the images of non-COVID, that is normal. These are normal chest X-ray images. So get back. This is the static folder. This folder contains files related to project styling and interactivity. They are CSS, JavaScript, and Bootstrap files. And here we have templates folder. Here lies all the HTML pages utilized in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website and provides structure, layout for displaying content to the users. So here we have app.py file. This Python file encompasses front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content that to be presented in HTML templates. And this is the model file which contain the algorithm information, and this will be loaded into the project code during runtime. And here we have notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. And the last file which we have is signup.db file. This file is a database file which is used to store the user information. So now let's execute it. First, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying it. Now open the Anaconda prompt. Here we need to give the command cd followed by the space and then paste the copied path. So now click on enter. Here we can observe that current directory is changed to the code folder's path. And now we need to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and it will perform a runtime check for any syntax errors or logical issues. So after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser. And this web page is built using Flask framework. So now click on sign up and enter all the registration details if we are registering newly. I already registered, so I will directly sign in. So click on sign in. Here we need to provide username and the password. So I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page. So here we can see a choose file. We need to click on that for uploading the chest X-ray images to detect whether the person has COVID-19 or not. So click on choose file. Here in the sample folder, we have the test cases. So open it. There are two folders. One is COVID and normal. So let's upload images from the COVID folder and see whether the application will correctly predict COVID-19 or not. So open it. So these are the test cases. So we will upload the first image, click on open. Here we can observe that image has been loaded, now upload it. So here we got the prediction for the uploaded image. So this is the uploaded image, and here we got the prediction as for the given input image, the cancer type is COVID-19. So it has predicted as COVID-19. Let's upload some more images. So click on try again, click on choose file. So now we will upload this image and upload it. So this is the uploaded image, and here we got the prediction as COVID-19. We can observe that the application has correctly classified as COVID-19. So let's upload some more images. Click on try again, and now click on choose file. So we'll be uploading this image, upload it. So here we got the classification as COVID-19. That means from the uploaded image, it has detected as COVID-19. So click on try again, click on choose file. So I'm going to upload this image, upload it. So this is the uploaded image, and here we got the prediction as COVID-19. So based on this image, it has classified it as COVID-19. When we upload all these images to the system, it will undergo pre-processing and then we will get the prediction. So application first, it will pre-process the given input image and then it will give the prediction. So get back, we'll upload some more images. So click on try again, click on choose file. So now we will be uploading this image. Click on open and now upload it. So here also we got the prediction as COVID-19. So let's try from the other folder, that is non-COVID. So click on try again, click on choose file. Here in the normal folder, we have the normal images that are no COVID images. So let's upload the first image. So this is the uploaded image, and here we got the prediction as normal. So we can observe that application has correctly detected that the person's chest X-ray, by looking at the chest X-ray, application has analyzed that the person has no COVID and he is absolutely normal. So let's upload some more images. Click on try again. Click on choose file. We'll be uploading this image. Click on open and now upload it. So this is the uploaded chest X-ray of a person. And here it has predicted as normal. So let's try using some more images. Click on try again. Click on choose file. So we'll be uploading this image. And here we got the prediction as normal. So here we got the prediction as normal, which means the person has no COVID-19. By looking at the chest X-ray images, we can understand that. So we'll upload one more image. Click on try again. Click on choose file. So we'll be uploading this image and now upload it. So this is the uploaded image, and here we got the prediction as normal. We can observe that application is correctly classifying normal and COVID-19. So now we will see the graphs of the project. So click on graph link. So this is the sample outcome graph. So these are the sample graphs. Here we have sample outcome 2 graph. So these are the graphs. So here we can observe that this is the plotted histogram for this image. So in this histogram, we have the distribution of pixel values of this image. So similarly, we have for all of the images also. And here we have train and accuracy curve graph, where on x-axis we have epochs and on y-axis we have loss and accuracy score. Here, blue color represents loss, orange color is the validation loss, green is the accuracy, and red is the validation accuracy. So we can observe that loss is less and we have high accuracy, which means that model is performing well. So now click on sign out. The MobileNet V2 based LDT algorithm, it represented a notable advancement in deep learning for medical image analysis. Its impressive accuracy and computational efficiency makes it a promising tool for various diagnostic applications beyond COVID-19, showcasing the potential for convolutional neural networks in improving healthcare outcomes. So in this way, just by uploading images to the system, it will accurately predict the COVID-19, whether the person has COVID-19 or not.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.